Hello again. So this time we're going to set up some harder word problems than you've seen before. Specifically these two types, integer word problems and age word problems. There are lots of different kinds of word problems, but we're only picking 4 or 5 types right now in this unit to focus on. And once you build up your skills, you can apply those word problem solving techniques to basically any word problem that you see in the future. So when we look at a word problem, we need to take care of some things before we do the solving. And that is, you read it and then you identify your unknowns. And then use a variable, set up some variables or variable to represent those unknowns. And then after that, we'll carefully analyze the language and set up equations. Well, for now it's probably just going to be one equation, and then we do the solving. The solving is something you've already done. You've already solved equations with variables on one side, variables on both sides, equations with parentheses, with fractions. So this is the part that is going to be easier for you. It's these two steps, identifying variables and equations, that will take a little time, at least in the beginning. So this is an example of an integer problem. I call it an integer problem because the answers are always going to be integers. Okay, so we have two sentences in this problem. Two numbers sum to 12, and twice the greater number is 40 more than twice the lesser. Okay, so we're going to first focus on the first sentence. Two numbers sum to 12. So if I call one of these numbers the greater number and give it a variable of x, then that means the lesser number has to be 12 minus x. Okay, so that is setting up the unknowns. X stands for my greater number, 12 minus x stands for my lesser number. And that all just comes from the first sentence. Okay, now I look at the second sentence. And I just translate the English from left to right as I read. So twice the greater number, so that's going to be 2x, is, means equals, 40 more than twice the lesser. So twice the lesser, which is this, plus 40, because of the 40 more than. Okay, this is the equation I'm going to solve now. I know I can solve it. I'm confident I can solve it because it's one equation with one variable in it. And so now we just go into the equation solving mode. So it's sort of like autopilot. Go through your priorities. First, I'm going to distribute here. And if you want to pause and continue solving it and see if you get what I get, feel free. Okay, so the greater number, remember at what x stands for, the greater number. The greater number is 16, and to find the lesser number, 12 minus 16 is negative 4. So my official answers are 16 and negative 4. Okay, Now, on to age problems. Kathy is 6 years older than her goldfish. Next year, she will be twice as old as her goldfish will be. Okay, let's focus on the first sentence so we can set up our variables. I'm going to make, since we're talking about ages, Kathy's age X. And if you notice, they're in this problem, they're talking about ages now. Sometimes they're talking about ages next year. So I'm going to be specific here and say X stands for Kathy's age now, not to be confused with next year. So if this is Kathy's age now, and she's 6 years older than her goldfish, that means X minus 6 is the goldfish's age now. Okay, now I move on to the second sentence, and I translate piece by piece. So next year she will be, we're talking about Kathy. So next year her age will be X plus 1. Will be twice as old as her goldfish will be. So 2 times what her goldfish will be. Her goldfish will be next year X minus 6 plus 1. Okay, equation is now on paper. I have one variable in it, so I can solve. You can pause now if you want to try it yourself. Okay, so I'm getting Kathy's age is 11, and her goldfish is 5. So Kathy is 11 and goldfish 5. Now there's an alternate way to do an age problem which might appeal to you. And that technique uses a chart. So after reading the problem, I set up this chart. And I put Kathy and goldfish in different rows. And for the columns, I will label them with the time, the period of time I'm interested in. So I'm going to place my variables and other expressions in these cells in my chart. So if Kathy is now X years old, next year she's X plus 1. If Kathy's X, then her goldfish is X minus 6. And next year, goldfish is X minus 6 plus 1. So it's just a different way of arranging the information given by the problem. Some people prefer seeing it in rows and columns, and some people don't care. They can just go straight from the reading the text straight to setting up your variables, and then straight to setting up your equation. The choice is yours. Okay, so that's integer problems and age problem. Oh, sorry, I forgot. There's one more age problem. It's slightly different than the one I just gave you. Okay, we have Sancho, who is 11, and Dan is 19. In how many years will Sancho be 3/4 of Dan's age then. Okay, right off the bat, you should notice there's a difference. In this problem, they tell you the ages of both individuals, current ages, 11 and 19. In the previous problem, they didn't tell you either age. They only told you how much older one was than the other. So right now we know Sancho is 11 and Dan is 19. Those are their current ages. The second sentence tells us what we don't know. We don't know in how many years Sancho will be this, 3/4 of Dan's age then. So X is the number of years in the future. That's our variable, number of years in future. So there's some mystery number that we're supposed to add to 11 and 19, because they'll be older, right? Such that Sancho will be 3/4 of Dan's age, 3/4 times Dan's age then. Okay, so my equation is going to express the situation in the future. So Sancho in the future, I'm going to put on the left side of the equation, and Dan in the future, I'm going to put on the right side. So on the left side, I want to write the age of Sancho X years in the future. He's 11 now, so X years in the future, he's going to be 11 plus X. And then on the right side, I'm going to write this part. Sancho will be 3/4 of Dan's age then. That's what goes on the right. 3/4 of Dan's age then. 3/4 times Dan's age then. Dan is now 19. In the future, he will be 19 plus X. So this is my equation to solve. Okay, we've got a couple things going on here. We've got a fraction, we got parentheses. I like to get rid of fractions first. Now distributing. Now I will SPE 3x and I will SPE 44. Okay, this tells me that 13 years in the future, remember what X stands for, it's the number of years in the future. 13 years in the future, Sancho will be 3/4 of Dan's age. So official answer, 13 years. Okay? So there are 2 age problems for you and 1 integer problem. In the next video, I'll show you a couple of other types of word problems.